Hello everyone, welcome to another JOTERific episode of our virtual class in mathematics. This is your JOTERific teacher, Teacher JOTER, and today I'm gonna take you to another wonderful JOTERific experience in the world of mathematics. Are you guys ready? So what are you waiting for? Let's go! Hello everyone. Today I will discuss to you set operations involving difference of sets and set complement. Before we formally start, let me just give you our objectives for this day. At the end of this lesson, you are expected to illustrate difference of sets and complement of sets using a Venn diagram and determine the difference of two sets and complement of a set. Okay. So I'm going to discuss first difference of sets, right? But before that, I'm going to give you a short definition of difference of sets, okay? The difference of two sets A and B denoted by A minus B is a set of all elements of A that are not elements of B. What does it mean? It simply means that to determine their difference, all you have to do is to take away all the elements of B that are found in A. Those remaining elements of A determines their difference. Alright? So the difference of two sets can be shown using a Venn diagram. Okay, let's take this figure 1. Right. As you can see in this figure, we have two overlapping sets A and B, meaning that sets A and B are joint sets. It follows, therefore, that sets A and B have elements in common, and that is shown by their intersection. To show their difference, that is A minus B, all we have to do is to take away the elements of B that are also found in set A, and that is shown by this part here. Okay, after taking away all these elements of A, we are going to shade the remaining region of A, and that is this area here. Shading that part will have this one. Now take note that the shaded region of A represents the difference between A and B, meaning to say the shaded region contains only the elements of A that are not found in B. Is that clear? Now let's proceed to figure number 2. We have here two disjoint sets A and B. It means that the two sets do not have elements in common. To show their difference, all we have to do is to take away all elements of B that are also found in A. But since the two sets are disjoints, it means to say that they don't have elements in common, right? So it means that we have nothing to take away from A. So to show the difference of A and B, we just have to shade the circle that represents set A, just like this, meaning to say we are taking all the elements of A as the difference between A and B. To better understand the concept of difference of sets, I'm going to show you some examples. Given the following sets A, B, C, and D, let us determine the following. Number 1, A minus B. Number 2, B minus A. Number 3, C minus D. And number 4, D minus C. Alright, so let's start with number 1. That's A minus B. Before determining the difference between A and B, all we have to do is to examine first the elements that are contained in both sets. Now, A minus B means we are taking away all the elements of B that are found in set A. Alright? So, take a look at set B. The elements of B are 1, 2, 3, and 6, while A contains 1, 2, 3, 4, 5, and 6, right? Now, we will be taking away the elements of B that are found in A. And what are those elements? Correct. Those are 1, 2, 3, and 6. Meaning, if we are going to take away all these elements of B from A, what elements are now left in A? Correct. So it means that A minus B is a set containing only 4 and 5. Alright. So I hope that you understand the concept. Okay, let's proceed to number 2. That's B minus A. In this case, we are taking away the elements of A that are found in set B. Alright? So what are the elements of A that are found in B? Okay, correct. So those are 1, 2, 3, and 6. Okay, so if we are going to take away all these elements 1, 2, 3, and 6 of set A away from B, what do you think are the elements left for B? Okay, correct. So if we take all these, there is nothing left for B. So therefore, B minus A is empty. Okay, so let's have number 3. C minus D. Let's take a look at C and D. What are the elements of C? Those are 1, 3, 5, and 7. While set D contains 0, 2, 4, 6, and 8. Right? Okay. Are there elements common between C and D? None. Take note that we will be taking away elements of D that are found in set C. Now, since there are no elements of D that are also found in set C, so meaning to say that we have nothing to take away from set C. So it means to say that C minus D is a set containing all the elements of C, and those are 1, 3, 5, and 7, or simply writing C or set C. Alright? So I believe that you can answer problem number 4, that's D minus C. So let's try this. Okay? D minus C. Again, since C and D do not have elements in common, meaning to say that we don't have elements to be taken away from D. So meaning D minus C is a set containing 0, 2, 4, 6, and 8, or simply set D. Alright? I hope you understand. Okay, so before we proceed to the next operation of set, let us have first a short quiz. Are you guys excited? Okay, let's have this. Given the following sets A, B, C, and D, I want you to determine the following. Okay, number 1, A minus B. Number 2, B minus A. Number 3, C minus D. And number 4, D minus C. Alright, are you guys ready? I'm gonna give you 30 seconds to answer this. Okay, so your timer starts now. Alright, time is up. Let us now check your answers. Okay, for number 1, that's A minus B. Okay, let's take a look. A minus B is a set containing 2 and 4. Why 2 and 4? Because the elements of B that are in A are 1, 3, and 5. So taking away 1, 3, and 5 from A, the remaining elements are only 2 and 4. That's correct. Alright, let's have number 2, B minus A. Okay, again, the common between A and B are 1, 3, and 5. So if we are going to remove 1, 3, and 5 from B, then the remaining element will be 7. Correct. Alright, how about number 3? That's C minus D. Okay, let's take a look. So the answer is 1 and 3. Why 1 and 3? Because the common elements of C and D are 2 and 6. So taking away 2 and 6 from C, the remaining elements are 1 and 3, right? Okay, so let's now answer item number 4, and that's D minus C. Okay, so common between C and D are 2 and 6. So meaning if we are going to take away 2 and 6 from D, that means that the remaining elements are, okay, correct, 0, 4, and 8. Okay, so the next set operation that we're going to discuss is the set complement. What does it mean? Here's the definition. The complement of set A, denoted by A raised to C or A prime, is a set of all elements in the universal set that are not elements of A. In simple terms, if you have a set and a universal set, whatever the elements of the universal set that are not found in the given set, those elements make up the complement of the given set. So to have a clearer picture of the set complement, I'm gonna show you a Venn diagram so that you will understand better what complement of set means. Alright? So I have here a universal set and set A inside. Notice that this set A is contained in the universal set, meaning to say that the elements of that set A are also found in our universal set. Okay, again, based on the definition of set complement, it means that whatever the elements of U that are not found inside A make up the complement of set A. So to show its complement, all we have to do is to shade the remaining region of the universal set outside that circle A. By doing so, we can have this. Okay? Now take note that the shaded region of that universal set outside the circle represents its complement. Okay? And always remember this, that the union of set A and its complement is always equal to the universal set. Let us deepen our understanding on the concept of set complement by having the following examples. Given the following, universal set U contains 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Set A, whose elements are 1, 3, 5, 7, and 9. Set B, whose elements are 0, 2, 4, 6, 8. And set C, whose elements are 1, 2, 4, and 8. We're going to determine the following. Number 1, the complement of set A. Number 2, the complement of set B. Number 3, the complement of the union of A and C. Number 4, the complement of the intersection of B and C. And number 5, the complement of the difference between A and C. Okay, so let us take the first example. Number 1, we are going to determine the complement of set A. Okay, so to determine the complement of set A, all we have to do is to remember that based on the concept of set complements, it is a set whose elements are found in the universal set but not found in the given set. Now, since we are to determine the complement of set A, all we have to do is to focus on set A and the universal set U. Now, notice that there are elements of the universal set U that are not found in set A, right? So what are those elements? Okay, correct. So those are 0, 2, 4, 6, and 8. Meaning to say that the complement of set A is a set containing those elements of the universal set that are not found in set A. And those are, again, 0, 2, 4, 6, and 8. Or we can say that complement of set A is set B. Why? Because set B is a set containing 0, 2, 4, 6, and 8. Okay, so let's proceed to number 2. That's B complement. At this point, we are going to determine the complement of set B, right? Now, we will be focusing our eyes on set B and the universal set U. What elements of the universal set U that are not found in set B? Okay, correct. So those are 1, 3, 5, 7, and 9. Or the complement of set B is equal to set A. Okay, correct. Now let's proceed to number 3. To answer number 3, we have to recall the concept of the union of two sets. Okay, so I've discussed that already in my previous video about the union and intersection of sets. But let me just give a short recap. Speaking of union, you are combining the elements of two sets without repetition of elements. Okay? So the first step to answer problem number 3 is that you are going to determine first the union of A and C. And that is a set containing all the elements of A and C. Distinct elements, no repetition, right? So those are 1, 2, 3, 4, 5, 7, 8, and 9. After getting all the elements in the union of A and C, all you have to do is to focus here and with the universal set U. Now, what are the elements of the universal set that are not found in the union of A and C? Okay, correct. Meaning, the complement of A union C contains 0 and 6. Do you understand? Okay, let's have number 4. Number 4 is about the complement of the intersection of B and C. Okay, just a short recap. When we speak about intersection of two sets, those are elements that are common to both two sets, alright? So take a look at B and C. Are there common elements between B and C? Okay, correct. So the first step to determine the answer for number 4 is that we are going to determine first the intersection of two sets. And that set contains... Okay, so we have 2, 4, and 8. Because 2, 4, and 8 are common between B and C. Now, after having the elements of the intersection of B and C, that's the time that we are going to determine the complement of their intersection. Okay? So, looking at the universal set U, the elements of U that are not found in the intersection of B and C are as follows. Okay? So, we have 0, 1, 3, 5, 6, 7, and 9. Meaning to say, the complement of the intersection of B and C contains these elements. Alright? So I hope it makes sense. Okay, let's proceed to the last example, and that is the complement of the difference between A and C. As what we have discussed a while ago, the difference of two sets A and C refers to the set containing the elements of A that are not the elements of C. Okay? So, to answer number 5, we are going to determine first the difference between A and C. And that set contains, okay, so we have 3, 5, 7, and 9. Correct. Okay. Now, that's the time after having the difference of A and C that we can determine the complement of their difference. Okay? So, let's go back to the universal set U. What elements of the universal set U that are not found in the difference between A and C? Okay, correct. Meaning to say that the complement of the difference between A and C is a set containing 0, 1, 2, 4, 6, and 8. Okay? So I hope that everything is clear about set complement. Alright, so before we end with our discussion today, let us have a short quiz first. Just a short quiz that would determine whether you've learned something from our discussion today, okay? So given the following, I want you to determine number 1, the complement of A, number 2, the complement of C, number 3, the complement of the union of A and B, number 4, the complement of the intersection of C and B. Okay? So I think that these are just very easy, okay? I'm gonna give you 30 seconds to answer the following. Your timer starts now. Okay, time is up. Let us now check your answers. Let's have number 1, the complement of set A. Okay, it is a set containing 0, 2, 4, 5, 6, 7, and 8. Alright, number 2, the complement of set C. So we have 0, 6, 7, 8, and 9. Number 3, the complement of the union of A and B. It contains, okay, so 2, 4, and 5. And for number 4, the complement of the intersection of C and B. Okay, it has the elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or correct. That is the universal set U. Well, I hope that everybody got a perfect score. Before we finally end, let's have another quiz. Okay? This is a matching type. Now, I want you to match column A with column B. Okay? So, given here, column A, these are different representations of operations of sets using a Venn diagram. I want you to find its pair in column B. So, given here are the following. Now, I'm gonna give you 30 seconds to answer these 4 items. Your timer starts now. Alright, time is up. Let's check your answer. Let's find out whether you've gotten the correct answers. Okay? So let's have number 1. Number 1 is for letter D. That's the difference between B and A. Number 2 is for letter B. That is the complement of the union of A and B. Number 3 is for letter C. That's the complement of the difference between A and B. And of course, number 4 is for letter A. Well, that ends our quiz and our discussion for today. I hope that everybody got a perfect score, and I hope that you've learned a lot today. Before I finally say goodbye, let us just first summarize what we have discussed. Well, today we have learned 2 operations of sets. The first one is the difference of sets. Remember this, that the difference of 2 sets A and B, denoted by A minus B, is the set of all elements of A that are not elements of B. Okay? And the second one is the set complement. Remember that the complement of set A, denoted by A raised to C or A prime, is the set of all elements in the universal set that are not elements of set A. Okay? And remember that the union of the given set and its set complement is always equal to the universal set. Well, I hope that it makes sense. Okay? So I hope that you've learned something today, and I hope that you enjoyed learning with me. Okay? Well guys, thank you very much for being with me today. I hope that you've learned another joterific concepts and techniques from what we have discussed this day. Well, see you again next time. This is your joterific teacher, Teacher Joter, saying goodbye and have a joterific day ahead. Bye-bye!